And so we said this is the square root. So what does it mean if I take the square root of a number? What? Okay, so we're trying to come up with two numbers that when we multiply them together, come back up with what's inside the square root, right? Which is the opposite of, or not necessarily opposite, but what else? Square root reminds us of what kind of? Squares, right? So we're going to say that it is the inverse of squaring a number So if I take the square root of 9, what is it? It is 3. And that's because, what is 3 squared? 9, exactly. Okay? So when we take the square root, we're trying to come up with two numbers that when we multiply them together, they come up with the number underneath our square root, or our radical sign, which we'll probably call, we're going to try to call it a radical. Alright, so with graphing radical functions, today we're looking at square roots, but we're going to move on that. So graphing square root functions, we're going to start with a parent function, which is kind of like our base, what we always want to start with and work from, because it's going to be a lot easier than just trying to pull things out of thin air. So our parent function that we're going to graph is y equals the square root of x. And how might I try to graph this? Yeah.
Set up a table.
Set up a table. Okay, so let's set a table of values. So if I say that my x is 0, what am I going to come up, what is my y? 0, right? So 0 times 0 is 0. And now if I go to 1, what times itself is 1? 1, good. Now I'm going to skip a couple of numbers and I'm going to go to 4. So 4 times 4 is 16, but we're going the other way. What times itself gives me 4? 2. Now if I had put 2 in my table, could you guys tell me what y would be?
1.
What's 1 times 1?
2 times.
It's a decimal, right? It's not a perfect number. So I'm deliberately going to put perfect squares on my x's because they're going to be easier for me to graph. That makes sense? Okay, so what number am I going to skip to for my x's? 9, yeah. And what is the square root of 9? 3. And we'll do one more. What's the next one? 16, and my y is 4. Good. Very good. All right, now what if I had, for instance, tried to put -1 in for x? What times itself is -1? I heard nothing, and I heard it's not possible. -1 times 1 is -1, but is that multiplying it by itself?
Yeah.
You can't multiply two numbers and get a negative, right? What? You cannot multiply the same number twice and get a negative number because you're either going to be multiplying a negative and a negative or a positive and a positive, right? So you're always going to get a positive. So let's go ahead and try to graph this. So we'll go 0, 0. And then we can go to 1, 1, 4, 2, and 9, 3. And you want to try and make a smooth curve? Mine didn't fit, so I'm going to stop at the 9.3. That's okay. How does this look? Does it look okay? It is curved. Because of the way the function works, it's not a linear function. By throwing in that radical, we're getting rid of we no longer have a perfectly linear function. All right, so there's two things that we can talk about when we talk about the way this graph looks. The first one is the domain. And what does a domain tell me? X's, right? So where does my x start, my x values? Where do they start? A 0, right? And do they get bigger than 0, or do they get smaller than 0? Bigger. So x is greater than or equal to 0. And the second thing we can talk about is the range. And what is the range going to tell us? What the y values can be, right? So where does my y start? Also at 0. And does it get bigger or does it get smaller from 0? Bigger. So y is also greater than or equal to 0. All right, so this is what I said. We called this our parent function. So this is the one we're gonna use to make everything else that we do. So now if I go down to this first one on my left, what is different about this function than our parent function? There's a 2 in front of it, right? So if I were to somehow try to change, what's going to happen with my table of values? Is everything going to double? If I were to go here and I say put 1 back in for x. Okay, so what doubled? Did the x double? All right, let's try a couple. So if I put 0 in for x, so I put 0 in for x, what we said the square root of 0 is what? And multiplied by 2 is still 0. So that one didn't change. But if I put 1 in for x, so let's say we'll put the same numbers in. We'll just go down to 9. If I put 1 in for x, what's the square root of 1?
1.
And we multiply it by 2? 2. Okay, let's try one more and see if we can see our pattern. So if I put 4 in, are you looking for your binder?
Yeah.
At the table. Alright, so if we put 4 in for x, we take the square root of 4, which we know to be what? 2. And 2 times 2 is 4. Alright, so now if I want to compare these really quickly. So here I have 0, 1, 4, 9. And on the right I had 0, 1, 2, and 3. Here I went 0, 1, 4, and we're going to try and figure out 9. 0, 2, 4.
Wait, where'd you get 0, 2, and 4?
So we put 0 in.
Oh.
We're working on this function now.
Oh, I got it.
Alright. So what doubled? Just the y's. So if you use the same x's, our y values are going to double. So what is going to go here with my 9? 6. Good. Alright, so let's graph this new function. So we're at 0, 0. We'll go to 1, 2. Go to 4, 4. And that's about all I can fit. So we'll go ahead and make our curve. And now if I really quickly draw, I'm going to redraw my parent function on my graph. It's going to be this guy right here. Try to draw it a little lighter. So we said the parent function was the plain y equals the square root of x.
Oh, it's always that?
Right now, today it's always going to be that.
And so far as those numbers?
What? So this function will always look like this is a graph, and this is a table. So my new graph, what's my new domain? So domain is which value? X. And do my x's get bigger or smaller? Or where does it start? Still starts at 0, and is it getting bigger or smaller? So it didn't change. What about my range? So y, and it still starts at 0, right? And is it getting bigger or smaller? Bigger. All right. So our domain and range didn't change by multiplying it by 2. But if we think back to, I don't remember what chapter it was, but when we talked about comparing graphs, what were some of the words that we used?
Vertical stretch.
Go ahead. Reflection was one. So we said, I'm going to list them right here. So we had a reflection. I heard vertical stretch from a couple people. And a vertical shrink. All right. So if this one's my parent function, this little one, smaller one, how does the bigger one compare? It's a vertical stretch, right? We stretched it, it got bigger. And it's actually going to be a vertical stretch by 2. And that 2 comes directly from this 2 in our function.
I mean, did we do something like this? Honestly, yeah, we did.
We did.
I remember myself. So we did do some things.
We've done vertical, we've compared graphs, yes. I just asked you. All right, moving to the second function. What is the only difference between the left one and the right one?
Negative.
The negative. All right? So now, if we can make our table of values, we'll start with the exact same x's. And how do we think the y's are going to change? They're going to be negative. So the opposite, here we can say the opposite of 0 is still just 0.
So are you using 149 wrong?
Yeah, I am.
We use it on homework.
Use what?
0, 1.
Yeah, you can choose whatever numbers you want to make a table with. And these ones are really nice because they work really well in the square root function. So that's fine. All right, so if we go to 1, if I were to put 1 in here, the square root of 1 is times negative 2. Negative 2. So we can also look back over here at this table, and it's just going to be the opposite. So we're going to go negative 4, negative 6. We'll get there. All right, so let's graph this one. So 0, 0, 1, negative 2, 4, negative 4, and that's as much as I can fit. And make it another smooth curve. Alright, so now what is my domain? So domain is what values? X. Where do I start?
0.
Starting at 0. And am I getting bigger or smaller? So x's we're thinking right or left.
Oh, wait,
We're going to the right or the left?
right.
To the right, which is bigger. Good. And now for range, we're talking about y. Where does my y start? Starts at 0. And is it going to go bigger or smaller? Smaller. So this one switches. All right. So if I draw my parent function, because I want to compare this to my parent function, so that's going to be be this one. So I heard Jack say it. What was a cup? There's two different comparisons here. What is one of the comparisons?
Opposites.
It's still a vertical stretch, right? So it's still a vertical stretch by 2, because we still have this 2 up here. And what else happened? We had a reflection. So it's mirrored over our x-axis. Good. So how are we feeling right now? Do we feel like we know? Yes. So 2 things happened. We had a vertical stretch by 2, and we had a reflection. Do we feel okay? Yeah? Alright. So now we're going to go to the back and kind of look at some general things that we could say. So this is going to look a little scary for a second, but we're going to break it down. So if I have y equals a times the square root of x minus h plus k. I know. It's a lot of variables, but they're just kind of placeholders that all tell us. They all tell us things. So far we've looked at a. So something being multiplied by our square root function, right? That's what the 2 and the negative 2 were. So a is something being multiplied. So multiply in front. And it tells us if it's a vertical stretch or shrink. What? It'll also tell us and reflection. And when is it a reflection? When it's negative. So we'll put negative. And do we know when it's a stretch versus when it's a shrink? Okay, there's a cutoff point. Do we know where that is? If I multiply something by 2, am I stretching it or shrinking it? I stretched it. What if I multiplied it by a half? Shrink. So that cutoff is going to be 1. So if we multiply something by 1, does it change it at all? No. So if we multiply it by something bigger than 1, then it's a stretch. If we multiply it by something less than 1, then it's a shrink. Okay. There's 2 other ways that we're going to be able to change this function, and it's with this h and our k here. First one we'll talk about is our h. If we have an h, which is something being either added or subtracted inside this radical, notice it's under the radical sign. So this tells us to slide left or right. And the key thing here is opposite the direction of what's underneath. So why might this be opposite of the direction? So here's my h. Kind of looks like an N. I'll make it taller. So we want to go opposite the direction. Why do we think we want to go opposite?
What's that one word next to
What? What is? Sorry. What's the opposite of 3? Negative 3. So what's something that we think of when we think of opposite? Negative? Do I have a negative here? Yes. So this negative is really important. So if I have a 3 here for h, we would move to the right 3. So it's very against what you want to do. So we need to be really careful with our h's. Now our k, so now I know how to stretch my graph, and I know how to slide it to the right or the left. What do we think k might do? Exactly. So k is going to tell us to slide up or down the same direction. Or the same as written, we'll say it that way. So this one, if it's a positive k, we're going to go up. If we have a negative k, we'll go down. So this one's a little easier for us to remember, I think. Okay? Feel a little better now that we know what they mean? All right, so now let's look at, we looked at our A's, so let's try to look at the other ones. The first one, okay, my very top left one. So am I adding something or am I multiplying something? I'm adding. Is it under the square root or is it outside?
Outside.
All right, so which variable does that represent? K. So I'm going to write that K is 3, just kind of as a mental note to myself. And if I go back kind of right up there to my notes, K tells me to slide up or down the same as it's written. Right, so let's start with our parent function then, because I told you this is all coming from our parent function, which is a reminder, was y equals the square root of x. So if I draw my parent function, which was 0, 0, 1, 1, 4, 2, right? We're just going to move everything up 3. 1, 2, 3, 1, 2, 3. All right, so that's our y equals the square root of x plus 3 is this one up here.
Is it always a good idea to start with 0, 0?
As your just first place to graph from, if that's part of it. I mean, to start here, I think so, just because you know exactly where it is. All right, so what's the domain of my new graph? Where does my x start at? So where's my x? So the point 0, 3, which one's my x? 0, xy. So we started at 0. Am I going to get bigger or smaller? Bigger. So my domain has not changed from my parent function. What about my range? So now we're talking about our y's. Where do my y's start? 3. And are they getting bigger or smaller than 3? Bigger. So this 3 right here is very important, and it comes from a very specific place. What? The K. This is not a coincidence. This is very important. So this K slid my whole graph 3. What? It'll have to do with your K, yes. It'll go one direction from your K. Do you have a question, Maddie? You're just stretching? Okay. That's fine. All right, so our range was changed by K. All right, so let's do the one right below it. Now, am I adding something, subtracting something? Adding or subtracting, we'll kind of combine those into 2, or am I multiplying? I'm adding. Am I adding underneath or outside of my square root? Underneath. So which variable is that? This one right here. Bottom left. I heard it. H? Okay. So what is my H? I've heard -2 and I've heard +2. So if we go back, and this is why the h's are confusing. You gotta be really careful with sign. So in this function, I have a negative sign. So what do I need to put into h to get a +2? -2. So h is -2. So it's the opposite as written. It's very confusing. Absolutely agree with you. So you got to be really careful and remind yourself of that. All right, so we'll start, rather than making a whole table of data, let's go ahead and start with our parent function again. So just 0, 1, 1, 2, 4. So that's our parent. H tells me to do what? Slide, or so how, just in general, what does H tell us to do?
Slide left.
Slide left and right. And we're going to slide left and right by 2. And this is the tricky part, is deciding which way to go with H's. So we said it's the opposite way that it's written. So it's written as a positive. So it's really a negative, which is why we wrote it this way. So we're going to go. It's a very standard use of when we use parent functions and transformations. So H is the one that's underneath it, right? The very top up here. So H is the one. So here's my H, and we call this one K.
Oh.
So when we add or subtract underneath, we'll use H if we want to talk about it, and K is the ones on the inside. And that way we can kind of differentiate them. All right, so we said we're going to go to the left. So let's start. You can start at any point you want. Go to the left, 2 to the left, and 2 to the left. And make your smooth curve. So this top one right here is going to be our graph of y equals the square root of x plus 2. What is my domain here? So I'm talking about my x. Where does our x start? Where does my x start? We're looking at this one. -2. And does it get bigger or smaller than -2? Bigger. And our range? Talking about y, where are we starting? 0. And are we getting bigger or smaller? Perfect. And just like our k affected our range, our h's affect our domain. Which makes sense because we're moving the graph up and down, so our x values are going to change. The other way, we're moving it left and right. Okay, try the next 2 on your own. The last one, we're doing more than one thing. We're actually doing 3. Do the top one first. It doesn't matter.
Do you always enter in the line first?
The parent function? If you can draw it without the parent function, no, that's fine.
So you said two up? Alright. Over one.
And then you just go back to instead
So you go over one of two, and then from there you're gonna go two and two, so it's like you have to go from there. Start from
Slide to the right.
So slide is the way you're thinking of it, slide is
It's up.
what you want to this is behind it. I can't help it. So that's how you decide. What is this to?
So like row versus slide up. Yes. So slide up to slide up to. I don't know. I saw this. What I did. So break it. Right one, and obviously it's 1, 2, and then stretching it by 2, so it's actually
that one. I got one.
It's negative, so. It's a negative, so you take the parent function.
I saw this. Oh, I wasn't that. It's just. Stretch out the hardest.
Draw that.
Because you won't say that. Still surprised.
Just like this line.
What? Is it? Wait, we're right. Oh my God. Okay, so it does matter. Is it on the outside or now? Is it under the skirt? So that's, we're trying to decide which is the opposite way. Okay, so it's the one outside right here. Jackie, so those are the theories outside and okay, so the first graph here,
So today.
yeah, the hardest word I guess. Oh, so land out to the did like your name and it's like 600 and it's greater like 600 and we had to like we had to and then we went all the way back. So that's so hard.
Greater than or equal to.
Is this a joke?
You went today.
Or we could sit here and wait until the bell rings.
Yes, we're going today. I promise.
Me too. Brendan seconds the hop on official too.
I didn't touch you. I know.
Wait, for real?
No, this wall is your favorite. She is not a teacher. You're so deep, but you're not a teacher. You don't teach it. You no, talk about this college. She's not a teacher, she's a helper. No, it's like an academic support.
I'm not.
I love this.
Oh my god. Jack, okay. You know why? Because I have feelings. You know, it's like it's a thing. It's like a big expression, but only breaks here and there.
And you don't get me?
Your homework is on the front side of your project. It is bookwork. It's on the calendar on the front side of the first sheet I gave you guys. So make sure you come with that tomorrow to do corrections and reflections. Wow. Right, you guys can go ahead and head out. Someone else. You guys can head out. See you tomorrow, Brenda.
Alright, I will.
Bye. See you later.